Okay, here we are back again doing more sample CLEP calculus exam questions that I found on the web at these location. Link also in the description. Before we begin, I want to revisit something from the previous video very briefly. So if you're watching these out of order, just skip ahead in this video for a little bit until we get to the next question. But this was number 28 in the previous video, and if you recall, is this messy limit trig thing. We were trying to find the limit as x approaches 0 for this monstrosity, and I said, well, the cosine close to 0 is going to be about 1. And if you subtract 1 from that, you're going to get some small negative number. And then that's also close to 0, and the sign close to 0 is close to 0. So if we're saying that a small negative number over two small negative, treating treating a very small number as like a variable unto itself, if we're treating negative n over n times n, and the next thing I did from that was turn it into n over 2n, and you might say, well, that doesn't look right. Shouldn't it be negative n over n squared, because those are being multiplied together, not added, and that would be correct. So what is really the justification for what I did, and there really isn't one. The truth of the matter is, if you have a calculator and graph this, or have a calculator and actually punch in some test values, some small values for x, you will find that they're both small numbers, but the denominator is twice as big as the numerator, so it does end up being negative 1/2, as we said. The only options are -1, -1/2, 0, 1/2, and 1. And we know it's negative, because of the top, so that kind of narrows it down to -1 and -1/2, and so you kind of got to, feel it out from there. These limit trig questions, when you can't use a calculator, it's almost more art than it is science. I think about the closest you could come quickly without a calculator, the smallest number that you could plug in and not have to, to be able to do it without a calculator, is a 1/2 pi. So if we did cosine of a 1/2 pi minus 1 over 1/2 pi sine of 1/2 pi, of course the cosine of 1/2 pi is 0 minus 1, and then we just have 1/2 pi, and the sine of 1/2 pi is just 1. And so that brings us to -1 over 1/2 pi, and that it's going to be -2 over pi, and we can approximate, just for the sake of what we're doing here, let's say pi is roughly 3, a little bit over 3. So that brings us to about 2/3. And we can say, well, 2/3 is probably closer to a half than it's closer to 1. And if you do graph this out and look at it, as you get any closer to 0, from 1/2 pi or -1/2 pi, it is a lot closer to the -1/2. But that's about as best you could do without a calculator and without a lot of time to do a better calculation. So just, limits and trigs, that's not a happy place for this kind of thing, where you're trying to get through things in a hurry. So that may be the kind of thing that you skip and go back to if you have extra time. That would be the kind of one that I'd worry the least about actually pulling off on test day. So now we will move forward to number 31, and we have a definite integral. So as a reminder, definite integral is just saying what is the area beneath that function, the area between the function and the x-axis. The tricky bit here is we have an absolute value around that function, and recall, I mentioned this in a previous video. It came up on a problem. When you're taking the definite integral, anything below the x-axis counts as a negative towards that area. Above the x-axis is positive area, below the x-axis is negative area. So what we're suggesting here by having an absolute value is probably this function dips below the x-axis at some point, at some area. But what the absolute value does is it takes that and flips it back up to the top. So we have to figure out, where that is and treat it differently, because instead of it being negative area, it's going to be positive area. So let's start out. We're going to consider that equation, and we need to factor that out. So this is basically unfoil type stuff, if you remember from algebra. So the question is what multiplies into 8 but adds to -6, and so that's going to be -2 and -4. Just guess and check in your head a little bit. So, and if we say y equals that, and if we say where does y equal 0, so we want to find the 0, we want to find where it crosses the x-axis. So what makes these 0? If x equals 2 or x equals 4, that makes y equal to 0. So that's where it's crossing the x-axis. But we're also interested in knowing, where in between, where the 2, between 2 and 4 onwards, where from those is it above and where is it below. So we have to know where we're dealing with a value that's already positive and where we're dealing with a value that's negative that we have to flip over to become positive. So we're just gonna do a little number line, and we're gonna check here. So if we say, what's the value of this at 1, x equals 1. So we have 1 squared minus 6 times 1 plus 8, and that's going to be 1 minus 6 plus 8, and that is going to be 3. So everything less than 2 is going to be a positive value. You can check it with other number. You can check it with 0. Plug in 0, just get 8. It's a positive number. We know that. So, and if we say at smack between 2 and 4, x equals 3. So what would that be? 3 squared minus 6 times 3 plus 8, and we get 9 minus 18 plus 8. So that's going to be 17 minus 18 is -1. So in between 2 and 4, that's where it goes negative. And just check real quick. For x equals 4, get a 4 squared minus 6 times 4 plus 8. So 16 minus 24, not at 4. We know it's 0 at 4. 5. We're going to test it at 5. 5 squared minus 6 times 5 plus 8. 25 minus 30 plus 8. And that's going to come to 3. So we know that this function, if you were to graph this out, it would be positive above the x-axis at x values less than 2 and greater than 4. And then in between 2 and 4, it's below the x-axis normally. But because we're doing the absolute value, that's where it's getting flipped upwards. So we have to account for that when we're doing the area for it. So we're nominally talking about the range from 0 to 6 for this definite integral. But we know between 2 and 4, it is that we have to flip it over. We have to negate. It's subtracting. We get a negative value. So if we subtract it again, then that makes it, it's a negative value. So if we subtract it instead of add it, that flips it to be positive. So, there's kind of a few ways you could go about doing this, but we're gonna break it up into 3 parts just as demonstration. So the definite integral from 0 to 2, and then we are going to subtract the definite integral from 2 to 4 because we're flipping the sign, and then we're going to add the definite integral from 4 to 6 because that's just itself. Again, the absolute value has no effect on it there. And so we got to integrate this now. So, as per usual with this kind of thing, we need to, just simple integration power rule, opposite of taking a derivative. So it starts as an x squared. We know that it's going to have to go up instead of, you go down to take a derivative. So you go up to do the integral. So it's going to be something x cubed. And to take the derivative, we'd be taking that 3 and bringing it forward to make 1. So 3 times what equals 1? That's a third. So there has to be a third there. And then we're subtracting. And again, we have x to the first power. So with an integral, it's going to be x squared. And you would have brought the 2 down, multiplied by something to make a 6. So 3 times 2 is 6. That's what would be there. And then there's no x here, x to the 0 power. So that comes as a result of having x to the first power there. And then that's just the same thing carried across. 3 definite integrals. Plus, we're adding that pit. Okay, so as with all definite integrals, how it works is you fill in the top value, the upper bound of the range, and then you subtract out, you fill in the bottom value of the range. So it ends up being a lot here. So we start with 1/3, 2 to the third, minus 3, 2 squared, plus 8 times 2. And then we're subtracting. Well, we can do this really quickly without writing it all down, because anytime you're putting 0 into all of this, it's just going to become 0. So we're subtracting 0. And then we are going to subtract this next bit. So we're going to start with the 4, the upper bound. 1/3, 4 cubed, minus 3 is 4 squared, plus 8 times 4. And then from there, we're subtracting. When you fill in 2, 1/3, 2 to the third, minus 3, 2 squared, plus 8 times 2. And then we are also adding, doing it with the 6. We have the 6. So 1/3, 6 cubed, and minus 3, 6 squared, plus 8 times 6. And we're subtracting 1/3, 4, the lower bound. We subtract the lower bound. doing in a hurry, so I hope I'm not messing anything up. Minus 3, 4 squared plus 8 to the fourth. And first of all, we notice pretty quickly that we've duplicated a few things here. For instance, we're subtracting this whole thing, but it's really like we're this one is if you take just this by itself, this is being added and that's being subtracted, right? But because we're subtracting that whole thing, we can actually propagate the sign through. Now we're actually subtracting this bit and we're adding this bit, and we recognize that we have some similar things going on because we have this one with the 2 filled in and this one with the 2 filled in. So it's going to be 2 times 1/3, 2 times all of that with the 2 filled in. And then we notice that we're subtracting with the 4 filled in for the x. We're subtracting it here and we're subtracting it here. So just consolidating a little bit so that when we actually run the math through, it doesn't take quite as long. And then you have to add when you do it with the 6. All right, and just to burn through this pretty quickly, 2 times 1/3 times 8 minus 3 times 4 plus 16 minus 2 times 1/3. 16 times 4 is, that's 48. Minus 3 times 16 plus 32 plus 1/3. 6 to the third. 36. 36 times 6. Not 36. 6 times 6. 36. And well, we're going to do a little shortcut here. It said 1/3, 6 to the third. Well, we know 6 divided by 3 is 2, so that actually becomes 6 squared times 2, or 36 times 2. That's an easier number. That's just 72. Save us a step there. Minus 3 times 36 plus 48. Lots of math to go through here. 2 times 1/3 of 8 minus 12 plus 16 minus 2. 1/3 of 48 is going to be 16 minus 48. Funny how that works out. Plus 32 plus 72 minus 108 plus 48. Really hope 2 times 8/3 plus 4 minus okay, going too quickly. First of all, 4 cubed is not 48, it's 64. So 1/3 times 64 is 2 times 64 thirds minus 32 minus 48 is 16 plus that's 120 minus 108 becomes 12. And if you multiply things through, have 16 thirds plus 8 minus 128 over 3 minus 32 plus 12. And if you have 8 plus 12 is 20, minus 23 is minus 12. That's 128 over 3, 16 over 3, and 12, 28 thirds, and 12 becomes 36 thirds. Nope, I've done something wrong. Did you catch my error? When I multiplied through the negative 2 with the 16, the negative should cancel out. That should be positive 32. So 8 and 32 and 12, it would be 52. Adding 52. So it's going to be 156 thirds, adding it. So 16 plus 156 minus 128, going to be 172 minus 128 thirds equals 72 minus 28. That's still not right. Where'd I go wrong? Yes, that's right. 44 thirds. Going too fast. Going too fast. A lot to do in this one. But if you run through all of those numbers and do it correctly, because there's a lot of places you could trip up and not a lot of places where you can take easy shortcuts, you do end up with 44 thirds, which is the answer there, C. Okay, moving on to the next one. That one, not complicated per se, but just was a long slog through all of that. Okay, number 32. Particle moving along the x-axis, and its velocity at time t is given by this equation. What is the maximum acceleration of the particle from time in between t equals 0 and t equals 3? So if we recall that if the original graph is like position, normally you have an x and a y on your graph, but if we say that x is time and y is distance, now your original graph is representing the distance that you are from some starting point at any given time. And the first derivative becomes your speed. It's telling you how fast you're moving. And the second derivative is your acceleration, telling you how fast your speed is changing. If you're speeding up, if you're slowing down, what the change in the first derivative is. So it's basically telling us that, here is the equation that's already the first derivative, and we want to know about the acceleration being the second derivative. So what is the derivative of this 12t plus 8? Make sure I copy it down right. So we're just going to do the derivative of this really quick, simple power rule type stuff. Bring the 3 down and subtract 1. Bring the 2 down times the 3 makes 6, and subtract 1. That's t to the first, so it goes away, and you just have 12. And then the 8 has no variable, so it just goes away. So there's the velocity, and this is the acceleration. And it's saying on the interval between 0 and 3, where is it going to be highest? And we could do a bunch of extra math to maybe try and prove it, but you note that you have a t squared there, so the biggest value out of any of this is probably going to come from there. And let's just take a quick guess. Maybe between 0 and 3, the highest value actually is at 3. So what would it be at 3? That's 3 times 9 minus 18 plus 12, 27 minus 6 equals 21. And you could plug in some other numbers just to check. I mean, if you plugged in 1, you would have 3 minus 6 plus 12, so negative 3 plus 12, you'd have 9. So obviously that's smaller. It's pretty reasonable to say that it's just increasing as you go along. So in the interval 0 to 3, it's probably going to be fastest at 3, giving you 21 that we found at D. And that is indeed the answer there. So, jumping ahead to number 33, and we have another one of these kooky composite functions, because at where x equals 0, if you plug in 0 here, square root of 4 becomes 2. 2 minus 2 is 0, so you have a divide by 0 problem, causing a gap in that graph. So they're telling you that where that graph is, that they're going to fill that in with a value they're calling k. And they're saying, well, what does k need to be for the graph to be continuous? What actually fills in that hole? So again, it's basically asking us what is the limit of the function as x approaches 0. All right, so we're gonna take it over here. We have x over 2 minus square root of 4 plus x. And the easiest way to do this, there's nothing really, well, you have to be a little creative in terms of this, but dividing by that square root stuff is not a fun thing. So our first goal is to get this off of the bottom. And the easiest way to do that, you can, anytime you have a fraction, you can multiply it by 1 and then turn the 1 into something over itself. So we are going to multiply that by 2 plus the square root of 4 plus x on the top and the bottom, because we are exploiting the fact that we know that a plus b times a minus b equals a squared minus b squared. And that means we are going to be able to get rid of that square root on the bottom doing this. It's tricky, but that's the trick. You got to remember, you want to get rid of that, and to get rid of that, you need to square this. So you get rid of that square root. You're still going to have stuff on the bottom, but you're getting rid of the square root. And to do that, you need to multiply by itself using this trick. So we get 2 squared minus the square root squared, so the square root goes away. And then we have the x on top from over there times the 2 plus the root of 4 plus x. So we also notice here that 2 squared equals 4. And we're subtracting, well, 4 minus x, because the negative carries through. And now we have an x on the bottom and an x on the top. So, that just turns into a negative x, and then the x's cancel out, and the negative carries up. So it becomes negative 2 plus the it would be negative 2 minus square root of 4 plus x, because the negative carries through there. And then, now remember that we haven't really changed the equation. We've just by multiplying it by this, that's just multiplying it by 1. So nothing has been changed. We've just been rearranging things so far. We've gotten rid of the divide by 0 problem, but other than that, nothing has changed. We just rearranged things. So the ultimate question is, what is it going to look like where x equals 0? And now that we don't have any divide by 0 problem, we can actually fill in for x equals 0. And that just simplifies to the square root of 4. And we get a negative 4. And so we can fill in negative 4. That's what fills the hole. And again, this is the kind of thing that if you had a calculator, you could check it very, very quickly. But without a calculator, you kind of got to do a rigmarole, try to get rid of that stuff from the bottom that's creating the divide by 0 problem, and having that square root there just throws in that extra wrinkle. But with a little trick, you can get rid of it, and it just kind of all takes care of itself. Very nice. So, next question, number 34. F is a continuous even function such that the definite integral from 0 to 3 equals negative 4. So if that's true, if you go from the definite integral from negative 3 to 3, but it's multiplied by 5, and then you're adding 1. So what is all that going to equal? And first of all, we're asking, well, what do they mean by even function? So when they say even function, what they're saying is that it has a symmetry about the y-axis. Everything that is on the positive side of x values, for the same negative x values, you're going to have the same y value. If it's positive y on the positive x, then when you go to the negative x, it's going to be the same positive y. It's basically just mirrored. So what we know from that, then, because we know that it's mirrored, we know that this is the positive half. Going from 0 to 3 is negative 4, but we know we're interested in if we're going out from 0 the other way to the negative 3, and because it's an even function, we know it looks the same. So we can say that the definite integral from negative to 3 to positive 3 of just that plain function on its own is 2 times negative 4. We know that's going to be negative 8. And so what is it asking us to do from there? Well, they are multiplying it by 5. So multiplying it by 5 just takes whatever you have and makes it 5 more, 5 higher, or, it has a negative area. So it's obviously going to be below the axis. So it's going to be 5 lower. So we have that negative 8 times 5. So that part is going to be negative 40. And then we're adding 1, but we're not adding, it's not added to the function. We can kind of break this up. We can kind of break it up. It's negative 3, 5 f of x, and negative 3 of 1. We can kind of break it across, because this is not part of that function. When you multiply by the 5, we're multiplying the function, but when we're adding the 1, you can split that off like this, and we can say we can integrate 1, and it's just going to be x. And if you can envision it in your head, x equals 1, or y equals 1 going across from negative 3 to 3, it's just going to be 6. And we can say upper bound minus the lower bound, and it's going to equal 6. So when we take this that we know is the negative 40 and add 6 to it, we get negative 34, and that is option B there, which is the answer. And then we go over to number 35 really quick here. And the graph of the function f shown in the figure, and it's one of these messy kind of functions that is really just several other functions just chopped together. It's there's no mathematical anything that'll give you something like this. They're just drawing a picture and saying this is what the function looks like, and is saying there's a vertical tangent at x equals 1. And by tangent, we mean slope, and by vertical, we mean the slope is going up and down. That's basically an infinite slope, because you can see it comes up into the semicircle and just going vertical. And a horizontal tangent at x equals 2. What do we mean by horizontal tangent? We mean the slope, the tangent goes straight across, which has a slope of 0. So we're saying that at the point 2, basically we're saying the first derivative here is infinity, and the first derivative there is 0. So we're asking, for each of these points, for 0, 1, 2, and 3, we want to say is f not continuous? Is it continuous but not differentiable, meaning you can't take a derivative, or you can take the derivative? So looking really quickly here, when we say not continuous, this notation here with the circle and then the dot elsewhere, we've been talking about that in other questions where you have like just like in this one here we did earlier, where you have some kind of divide by 0 error that creates a gap in the graph, but then they give you a second piece that fills in that value, and if you match the whole, then you've filled it in and it's continuous. But if you take that value at that x and say it's somewhere else, then when you get to the gap, you jump down and then jump back up, and you're not continuous. So pictorially, that's how this is represented, saying that the value at x equals 0 is down here when you would expect it to be up there. So that is where f is not continuous. And then in terms of where can we take a derivative, where can we take a derivative and where can we not take a derivative? Well, we already acknowledged that at 2 you have a slope of 0. That means the derivative is 0, and that means you have a derivative. So that's definitely true there. But at 1 we said that the slope is infinite, and that's not a proper derivative. So it's continuous, there's not a hole there, but you can't take a derivative that equals infinity. It's not proper. If you tried to take there's no equation here that is something you can take a derivative of. And then also at 3 you have this sharp corner where whatever formula makes this and whatever formula makes that do not possibly match up. It's just two things that don't match up. You have that sharp corner. You cannot take a derivative at a thing like that. So it's continuous. There's no hole there, but you can't find the slope at that point because it's not smooth. So that looks like that. That's the answer there. And that's it for this video. See you next time.